Hello, Internet Land. It's the Balena IoT project number 2. So this is our session where we talk about projects and showcase some projects, but mostly we want Q&A. So first shout out, if you have a question about your project, bring it in, put it into the chat, and we'll try and answer it if best we can. And the other thing we might do is we might go and talk about some common questions we see in the forums and try and answer those and see if we can help as many people with those answers as possible. Let's go round the room. God, that felt like such management spin speak, didn't it? I don't know, that's like my terrible past coming back to haunt me there. Let's introduce ourselves, but not take ages over it. That's what I was going to say. So I'm Phil Wilson. I'm a product builder at Balena. Go, Andrew.
Hey, Andrew Nam, product builder, lead content strategist at Balena, helping make awesome web things. Yeah. Your turn, Kyle.
Wow, so good.
I'm not sure how I can top that. I'm Kyle. I'm an OS developer at Balena.
Peter.
Is that it?
Hello, everyone. I'm Peter. I'm a full stack developer trying to work on Azure here at Balena.
Trying to keyword.
Yeah. Alex.
I'm Alex. I'm an engineer working on hardware-related things, but also everything else generally as well.
Yeah, he's generally called Buckles, so you've probably heard him mentioned in the past. But Dr. Buckles, but not known that's who it is. Right, so episode 2. Let's talk about who's got a project that they're going at the moment. Peter, you've got a project at the moment. So for the audience, we've got a new thing that we're running at the moment in Balena, which is something called a labs residency. So we have a team within our team called Balena Labs, and they're kind of like an R&D experimentation team, like advanced users, but they live within Balena. So we've got a new thing at the moment where when people come into Balena, they do a residency in that labs team, and that means to make a project, and it's like field studies. So try and live the life of a user so that when you then go and do the job you're eventually going to go and do, you've already lived the life of the user and you sort of understand where their pain points are and how they use the product and that sort of stuff. Peter's one of the people who's very kindly agreed to come in and try this residency while we're building it around him. Like typical Balena style, we never go away and come back with a finished thing. We always build it live whilst people are trying to use it. And Peter, your project is to automatically open and close the curtains in your room. That's right, isn't it?
Yeah, it is about that. And actually, you can control anything else where you connect those motors. Yeah, the main idea is to use some sensors, define some logic when the sensor is reporting some values, then do something with the motor. So yeah, first let's try with curtains and maybe then with something else.
Yeah.
And this is really
Can
cool.
you open those curtains behind you yet? I would like to see you right now.
Live,
I just want
live demo, go.
Yeah.
On the spot.
I don't have the hardware yet.
Yeah.
So I have everything on the software side.
Nice progress.
Yeah, I really need to get the motors, assemble it, and then do a nice demo because I'm really excited to see it work finally.
The global hardware shortage caught up with Peter, and it's something we need to think about with the residency, that people come in and they've got a project in mind, and then you can do all the software and you can start writing your blog post, but until you get the stepper motors and your sensors, can't actually build the thing.
We just need more projects to deal with the hardware shortage. So optimize for the hardware shortage.
Products
I love your style, Buckles. Yeah.
Yeah, Buckles, you haven't done a residency yet, have you?
Everything's a residency.
That's true. What I do like about projects like Peter's is, you can kick it off, and let's say it's we're 6 months down the road, and you have a V1, people can use it and whatnot, but there isn't really that far of a gap from some at scale larger org taking it and putting it in their entire apartment complex. that part's always my favorite, where it's like any idea that comes through that we end up building, blenifying even, can turn into something really big and awesome, or it stays your hacked on project. Like that whole, the range is so neat to me.
And it's another good example of like part of the Balena culture is that we have this idea of serendipity engineering where sometimes we do things we're not quite sure why we're going to do them. It might just be they're interesting, or we think it's going to be cool, or other people might be interested in us doing it. And then something comes of it and everybody's like, oh, that was a really good thing you did there. Like it made this block and it made this other project. But like sometimes these just happen almost by accident because you know it's a good idea, but you don't quite know what you're going to get out of it.
Yeah.
I've actually encountered things that like I'm wondering if it's even possible with a normal like container stack, Balena or otherwise. So I hack on it until I find a way to break things in such a way that I've achieved the desired result, and I end up using that in support when customers have similar questions. I can be like, well, this isn't how it's designed, but here's a fun workaround that I hacked on over the weekend.
Yeah. And I was talking to another person who's doing a residency at the moment, Eduardo, shout out to Eduardo. And he was saying he's got like a Raspberry block that he's making. So now he can do voice commands to his Raspberry Pi and it'll do things based on the voice command he's given it. And he was like, what I need now is somebody else doing a project that's controlling something in their house. And I was like, Peter's got controllable curtains. Let's join them together. So yeah, you never know what's going to happen. And that's one of the amazing things of labs and residency and just building projects in general. That's why I'm so stoked about this whole clinic. Like you never know what's going to come of building projects.
That's true.
So everybody out there, build projects because it's lifeblood. You never know what's going to happen.
Oh, hey, check out this suggestion here. Blocks as a service. Well, Phil helps you write a block while playing bass heavy music. Let's do it.
Yeah. So what I thought we could do today, we're still growing this. This is another example of something Balena are building in the open while people are using it. This whole project clinic is another example of that. So what we do want to do is build up to having people calling in and joining the stream, or add your comments to YouTube, or Balena people come in and ask project questions, and like hopefully it'll be more of a Q&A than anything else. But while we're still waiting for that kind of community and process to build up, I thought what we might do is perhaps ask some questions that we've seen in the forums and are sort of common questions. And if we could answer those live, then that might help a bunch of people. And we sort of seed the questions ourselves for a few weeks.
Actually, I've got one to start since I am actually looking at my residency perhaps in a month or so.
Breaking news. Yeah.
Yeah. Well, that's the cool part. I mean, just to kind of talk meta for a sec, it's not just for the newcomers, right? Like current balenistas, maybe we need a break from the norm. Maybe we've gathered all this context from projects and whatnot. We just want to scratch some sort of intellectual hacker and maker itch that we have. I really love that we have that window to embark on that.
You not only have that window, but it's super encouraged that everybody has a project they're hacking on, or several projects they're hacking on, but like one main one that you care super deeply about, because like you say, sometimes you've lived in an abstract, very long-term world. Like maybe you're on a project that's completely redoing the whole Balena CI, for instance, and it's going to take a long time for us to do that. And it's lots of architecture calls, and it's lots of thinking in abstract ways and trying to design together, and not very much type code. So sometimes people need like a break to just do something that they know how to do. And it might even be mundane coding, for instance, but sometimes your brain sort of needs that, just get something done. And I'm in control of it myself. So like, it's really good to have a project for that. But again, serendipity engineering, you never know what's going to come of your project. It might even tell you an answer to the abstract idea that you've been trying to work out for ages. You never know. It's happened so many times. So yeah, everybody's encouraged to have a project. And if you need a residency to kick it off, or because you get stuck and need to concentrate on it, or you just need a break and need to come and do a residency, then yeah, it's completely something you can do in Balena. So lead content geezers coming to do a residency.
Yeah. So this question probably shows my experience level. I'm always down to learn by doing, work on stuff. The more drag and drop and like more already editable things I can use, the better. And this question's around hardware choice, because while I trust, like, if Alex were to give me a code base to start from, he'd be there to help. But like from a hardware standpoint, it's like quality varies, right? So I'm staring at a couple pH sensors, and I'm wondering, in this project that I would like to utilize some pH sensors for, I found some way like super duper affordable ones, which may or may not be related to their quality. But I could also very much spend 10x on something much more expensive, but then that would kind of put me in a bit of an investment hole there, just to like prototype a thing. In y'all's experience, what's the best way to roll? Like, do we start with cheaper, more affordable things? Does that inhibit and maybe like potentially sabotage results down the road? Should I go big?
Where's Alan when you need him?
What's that?
Where's Alan when you need him?
Oh, I know. Paging Alan.
I'm sure you'd have a great answer for this.
We don't need Alan. We've got Buckles.
My take on it would be start with the cheapest thing possible to get it working, and at that point you can then refine. I mean, as long as you can verify it, like from an external source, that whatever you're reading from your sensor is ballpark, I would just start with that, and then I'd narrow down onto it and to get the precision that you need. Like I was doing a project a while ago with, I think, a temperature sensor, and I was getting an offset that was really weird, but it was in the ballpark of what I was expecting, and I was seeing the temperature change. It was just an offset. It was like a positive offset to what I was expecting the room temperature to be. So at the end of the day, I was like, well, it's pretty consistent across all of the samples I've taken. So I just accounted for it with software, and I just said, okay, well, take off 2 degrees from the temperature it's expected, because maybe it was being artificially increased by the thermal output from the Raspberry Pi that it was attached to.
Mm-hmm.
And it's that kind of thing. I say, like, if you can validate from an external source, if you like a pH sensor or something that you could check it against, maybe not one that you can integrate into your project, but one that you use before you build your automation or something, I would build against the cheapest thing and then just compare it against a known value before you decide to commit to buying a more expensive sensor.
Yeah, okay. My simple sensor in my bedroom is about 2 degrees warmer than a sensor almost right next to it, and I can only assume it's because it's like 2 inches away from a Pi. That's probably heating it up. So whenever I look at my graphs and I see that it's really warm in there, I didn't even fix it in software. I just mentally subtract 2 degrees and assume it's a bit correct.
And it can even be the copper traces. So if you plug a hat in, all those copper pins could also be thermally conducting from the Pi itself. So it might even not necessarily be on top of it. If it's even attached to it, it could still be pulling the heat off of the Pi.
You're saying my soldering job could have made it worse?
Possibly.
See, I tend to go the other way, and I wonder if this is the difference between hardware dudes and software dudes. I always buy like the name that I know, even if it's a lot more expensive, and I can see one on websites that are, a couple of dollars, and I'm paying $20. Because the thing is, then I've probably got a tutorial to follow to get it up and running. I'm kind of knowing what I'm going to see because I've got something to follow, and then I know if it's not right. I think maybe Alex's view of it is more along the lines of he knows how to deal with hardware if it doesn't seem to be working, and he knows how to sort of check it for himself and work out electrically if it's doing the right thing. Whereas me, I'm just, if it plug it in and it doesn't seem to do anything, I don't know. But if I've got an Adafruit tutorial to follow, then maybe.
Yeah.
I'd also argue that I poured so much money down the drain buying crap that I think at this point I need to start considering my investments more wisely. So.
Yeah.
That's really
helpful. We're in a chip shortage, Alex. What are you thinking?
No, not anymore. I've been very good the last 6 months. I haven't been impulsively buying components because I know that the wider world needs them, not just my random weekend projects.
So I'm definitely going to use what I've got in my garage, but I do like the recommendation of like, hey, in code, adjust for variances based on what, other proven tools. I just have to remember to remove those things, right, when I push it live or the GUIs, because they're going to be like, why is this off by 3 degrees?
Yeah, or that's a configurable thing. Like if you know that an offset is going to depend on hardware and you're making a block or an app, just make your offset configurable, default it to 0. And then when you deploy your personal app, you set it to 2. If you know it's something that's going to be flexible based on hardware, then just document it and expose it as an environment variable, I think is the cleanest way to do it.
Cool. Yeah. That's good advice. Thank you, guys. I feel like I know how to move forward now.
All right. Another one I was going to talk about, like I saw this in the forums, that sometimes we get about open fleets. So for people who don't know, if you go to Hub today, hub.balena.io, you can see there's two different types of thing. Well, three. One's blocks, which is kind of fragments of apps, where we talked about that in previous streams. But the other two are projects and fleets. And with fleets, basically what you're doing is you can add one of your devices to a fleet that's already running some code, and you don't need to upload code, manage code, update it, configure anything. It will just work for you. So it's kind of like buying a device with the firmware already built in, only the firmware is open source and you can go and fork it and run it yourself, or you can just stick with the default one that comes down. But we do see some people who join a fleet, let's say something like Balena Sound, and then they feel like the device isn't working, and then they unplug it and they go off and do something else. And I wanted to sort of try and answer that. We see that quite a lot of people saying, like, I joined Balena Sound fleet, but nothing happened. And I wanted to try and sort of maybe explain what's happening. So what's happening is you join the fleet, you flash your device, and it joins the fleet, and your device is part of that fleet in Balena Cloud. But then it's got to download the services. So in Balena Sound, you've got things like the audio block, the Bluetooth block, Spotify plugin, AirPlay, these sort of things. And all of those have still got to download onto your device before your device then does its job and plays sound. And depending on your internet connection, that might take quite a while for those things. Like you could be waiting 5-10 minutes for all those services to come down. There is a long-term piece of work where we'll be able to preload things so that you download the initial image and flash it to your device and all the code's already there. But that's still coming. It's still work that we're doing at the moment. At the moment, you join the fleet and then all of the services download. So that's one thing, that if you join something like Balena Sound Fleet, you just need to give your device a few minutes. There are a couple of things that you can do. So if you do have a HDMI plug and you've got either a monitor or a TV with HDMI in, you can attach it. And so, for instance, if I share my screen, I took a photo. This is a HDMI attached to my Balena Sound device. I didn't mean to stop sharing. What it does is it gives the console logging. It will put it out onto the HDMI display. So you can see, like, my sound supervisor is running my multi-room server. So it gives you an indication. It will say downloading, or it will say running when they're done and running. So the device is sort of doing something, and you can watch that progress on your display, even though you don't have Balena Cloud to log into and see what the device is doing, because it's part of the open fleet.
Is that the case for all fleets? That's a core feature, or is that something we enabled for Balena Sound?
It's a block called log to screen. So if you put that block into your project, so put that piece of Docker Compose into your Compose file, then it will just take whatever is being logged to the screen, but just like the services. So it's taking the Balena logging and it will put it out to HDMI for you.
Very cool.
That login is just a curl command. So it's just curling and then JQing the result so that it prettifies the colors for you and puts it on the screen. That's all it's doing. And it's a tiny little shell container. So you might as well add it to projects if it's going to be an open fleet, and then your users have another way of knowing if there's an issue or not.
Yeah, that's a good idea. They can, especially for something like Balena Sound, where some of the containers are still a little bit big right now. It would be nice to be able to monitor the progress from like an HDMI monitor.
Mm-hmm. Yeah.
So for the people who don't know the hub, is there a way where they can easily check what is inside that project?
Yeah. So if you go to Balena Sound, if I use the Get Started button, then I'm going to, let me get that. Could you take the sticker off my head, Andrew?
Yeah,
I'm hidden. If I use this Getting Started button, then thanks, mate. Then that's going to download the image, and then I can add my device to this fleet. And I don't see what the device is doing necessarily. It's just going to start running up, and eventually it will start doing Balena Sound jobs. If you want to see what is actually running, then over here is view code, and that will take you to the GitHub repo where Balena Sound is stored and maintained. And then you can dig into all the code. All of it's open source, and it has to be open source to be on balenaHub. That's one of the restrictions, that we can't have closed source and paid for type things on Hub. It's for open source software. So yeah, go and dig in and see what it does. There's also we've got these things called Landr sites, which is kind of all of the documentation that we put into our projects can then be used to generate a website about that project. So Balena Sound, its documentation generates this site. So if you do deploy Balena Sound and you find you're getting, it's not working for some reason, and you've waited a long time and it's definitely running all the services, etc., then if you go to sound.balenalabs.io, then you can dig into things here. One of the most common things we see, I think anyway, is people will say that it started and the services are running, but no sound's coming out. And there's things that you need to do, like either you're using a USB sound, a dongle, or you're using the 3.5mm jack and you need to put that in. But like one of the main things is that people have got a DAC, so they've attached a board that is then going to, go out to their speakers or whatever, their hi-fi, and they've not configured the device to work with the DAC. So if I show you, here's my fleet. If I show you the garden one, so I've got one in the garden and one in the living room, and in the device configuration, you can see I've got this DAC configured here because it's running a Hi-Fi Berry DAC Plus, because that's got an amp on it, and this is running in the garden. So there's an outdoor speaker, and it's attached to where my children play. So they've basically got a garden jukebox running Balena Sound. But that's got a little DAC running on it to drive that big outdoor speaker. So I've had to configure that. And I've done that in this Balena host config DT overlay. So if you go back, you'll see on the DAC configuration, it tells you how to do that. And it also tells you, depending on what make of DAC you've got, what value you need to put in that DT overlay so that it picks up the drivers for it and can control that DAC. So those are like two really common things that we see. People deploy Balena Sound and it doesn't work. And if they join the open fleet, maybe they just need to wait for all the services to come down. And in future, that'll be preloaded and you won't have to wait. But for now, you do have to wait. Plug in an HDMI and see whether you get an output and see whether your services are beginning to run. If everything appears to be running, then you might need to configure a DAC. If you're in the open fleet and you can't get, therefore, you don't have this screen that I showed you. Luckily, we've got you because you go to balena.local. That device will be running a little web server and it will give you a local configurations. We call it local UI. So in this case, I can set a DAC. So this is the living room one, which is why this one hasn't got one there. I can change the volume and I can even do things like look at the logging. If I have got a problem, then I can go to the forums and paste that logging and I can reboot the device, restart the services and things like that. So hopefully that's going to help some people that have got problems with Balena Sound or are going to try it this weekend, and if it doesn't work straight away, then that's like the things to go and look at. Anybody else?
I think you thoroughly answered Peter's question.
It's a bit of a ramble, wasn't it? Yeah,
nuts.
I got going.
You did hit at a couple of really cool tools there. I know our fearless Landr leader, Amit Solanki, is really close to a V1 of the tool. And the point is, it's our easy to use, software focused static site generator. I mean, yeah, there are like a million static site generators out there, but this one in particular, it lets you generate just a beautiful, usable website so that you can focus on your code. We want to extend that out to folks who are building their own projects. We even have plans on using some of the goodies within Hub so that at some point these pages are much more open source standards driven. You have like a micro site almost, but if you want to spin it off and do something on your own, you can do that too. So more to come there, but know that the team.
And you basically just document it in the GitHub repo, don't you, with normal Markdown, and it will just generate the site based off your Markdown. So you're already doing what you wanted to do anyway, but documenting it alongside the source code. Yeah, but like just as a freebie, it makes you a mini site based off it.
Yeah, we definitely want to ride the wave of folks who are really into document-driven development, just so that people can really focus on making their big idea come to life and not worry about, hey, did my site render properly?
Yeah. Good point to remind people, anybody watching, if you've got a question about a project, then stick it in the chat and the panel of people here will try and answer it. While we wait for questions, we'll just keep digging into ones that we already have or ones that we could answer. Mr. Buckles, while you're on the stream, I do want to make the most of the opportunity to talk to you about the fin, but more the fin block. Because last week I talked about the fin block but you seemed very upset that I glossed over it with a hand wave.
Is
Put a lot
this?
of hard work into that block. I was upset
So-
that we only got a glassing mention.
So what, like, treat me like I'm 5. What is the balena fin, and why do we need a block for it?
Let me find one. Oh, conveniently, I have one in front of me.
So do I actually, just for this.
Oh, really? So the balena fin is our industrialized carrier board for the Raspberry Pi compute module. And what this is basically is a Raspberry Pi with a whole bunch more features on it designed for industrial application deployment in real world situations. So we have things like a wider voltage supply, so we could take voltages from, I think it's 6 volts all the way up to 30. There's eMMC on board, so you have to worry about SD cards getting corrupted. We have a coprocessor, 2 forms of different power-ins that are typically found in industrial scenarios. There is a slot for a modem, cellular modem, or other MPC card. And basically, these boards are designed for deploying in the real world, where you actually expect something to have to survive for many months or many years unattended. And to follow on from that, what we did with the concept of the fin block is we wrote some software in the concept of blocks to basically allow you to use some of the functionality built into the balena fin in a more efficient and more effective manner. There's a lot of things that the balena fin can do that require a bit of digging to perform them. So one of them, for example, is the coprocessor can actually sleep, power down the main board, so you can extend battery life if the device is running on a battery. And the balenaBlock that we have for the fin allows you to very easily do that from a web interface. And so here you can see our very lovely design Landr page.
This is like super preview, isn't it? Like this is alpha. Yeah.
So we're quite excited that we've been able to try out Landr for a block, which is, I think, we're the first block to mess around with using Landr to generate our documentation, and it's been super easy. I mean, to give kudos to the Landr team, I think I got the first version of the Landr page running in like half an hour, threw together the template they're expecting, and then hit commit, pushed it, and then we had the first version of documentation, which is really awesome.
So this is how you include it in your project. This is the sort of Docker Compose snippet you'll need to put in.
Yeah, so you have this alongside any other services that you want to expose. The idea is that with a block, it's a complementary thing. So you'll have an application running, and then the block will provide you condensed functionality in the form of a ready prepared Docker image. In this case, the fin block.
And then, so now if I add this to my project, what's it going to do for me?
So right now there's a couple of things it'll do. It'll expose a web server, first of all, with a REST API where you can ping across some requests to do specific things like, as I mentioned earlier, sleeping the fin. You can also use it to extract manufacturing information about the device. So every device that we manufacture goes out with the manufacturing date, the batch it was manufactured in, the version number, and a couple other things encoded in its serial number. Our customers that are deploying larger fleets like to have this information because it's really good for troubleshooting. So if a device goes down in the field, we can get that information off of them and say, hey, let us know which device this was. We can check it against our quality and testing to make sure that it's not anything that happened from factory, and we can guarantee that it's going to perform as expected in the field. And also it's a nice unique identifier for us to make sure we're tracking exactly which hardware is running a specific task. What else can it do? So we've got sleeping. We've got the
Tell me about sleeping. Hang on, because that's like a weird idea, isn't it?
Yeah.
Like what? How can we sleep a device, and how do we know it's going to come back?
So traditionally, with fairly intensive compute, you don't really have a concept of sleep. You have like hibernation for like Windows machines or x86 platforms, where the machine kind of goes into a low power state and you can re-wake it up again. That isn't typically something you would really want to have running on a battery, at least for a device that was deployed for a long period of time. You would quickly still burn through a battery in a hibernation mode. But what we have with the balena fin is actually the ability to shut down everything except for the coprocessor, which can then either be woken up on at an interval or with an interrupt. We still need to expose the interrupt stuff from the block, but that's coming. And so what this means is you can get into a really, really low power state where it's just the microcontroller running, and that's much more effective in terms of power consumption. So I believe we can sleep the entire fin for many years if you really wanted to, only running with the coprocessor live.
Have you done that?
I don't have anything running right now.
The one he's holding is asleep. Like,
Yeah, this was asleep, but that's only because it's not plugged in. But in theory, you can imagine a situation where you might want to do that. So, say for example, you had a balena fin that was in some really remote situation. Maybe it was like I don't know, stuck under a bridge, monitoring vibrations, looking for. This is a very specific situation because it can't stop in my mind.
Right.
But you're looking for like damage in the bridge, maybe, and then it had a wake up event where it maybe noticed something weird. The coprocessor noticed something weird happened 2 years after deployment. You wouldn't want the device live for 2 years because you'd just be drawing the battery the whole time. If you could wake up on that event occurred, send your information, and then go back to sleep, that's typically something that's reserved for really low power microcontrollers. But now we have that feature on a fully functioning Linux board. So it really opens up the door for what you can do with that.
Continuing to explain like ROLF 5, how much power does the coprocessor draw compared to like the actual CM3 or 4?
So the coprocessor currently, I mean, there's actually more work to do on this to get it even deeper into sleep. It's just a time thing we haven't had a chance to do yet. But it draws about 1 to 2 milliamps of current at 3.3 volts. So it's pretty insignificant compared to some things. You can get lower than that, and actually we can get lower than that with it. I think the ultra low power modes for the coprocessor are in the region of like 1 to 2 microamps. So that's really like, you don't have to worry about this thing running out of battery. It'll quite happily last for easily years on end.
Your battery's going to drain on its own faster than that.
More than likely, yes.
Yeah.
Compared to the whole board up and running on its own, I mean, that's drawing in the region of like 1.5, 2 amps at 5 volts. That's typically what a Raspberry Pi draws. And that's significantly more power consumption than what the coprocessor is using.
Cool.
So you can imagine, I mean, I don't know if you've ever played with like the what do they call them? Like the Pi supply battery, what do they call it? Pi juice? Pi juice.
Yeah.
I mean, those are great, but they're more intended as like a couple days solution rather than like a week or month kind of deal, because the Raspberry Pi itself draws so much power.
Mm-hmm. And even something like a Zero or a Nano Pi, you're still not going to be able to get it down to a power usage the same as you can a micro coprocessor and save the actual main processor.
There's a lot more going on in a system on chip like a Raspberry Pi than there is in a microcontroller. So there's a lot more peripherals.
Somebody had a cool use case not so long ago. I remember it might be Mr. Chris, the hairy labs god. He was saying like he liked the idea of making a geocache but have a fin as part of the cache. And so like when you open the cache, it triggers the fin to turn back on, and then something happens. It takes a picture of the person, it logs where it's been put via GPS, it sends a signal to say it's been found or whatever it is. Or maybe it's like part of the geocaches. Some of them have got puzzles you have to solve. So like maybe part of the puzzle is part of the fin is part of the puzzle. So like that seemed like a cool idea, because that might not be found for months on end, but then the person opening the box triggers it.
Yeah. I love the idea as well of something like like the wildlife trap cams. So it triggers on the movement of something. So if you had like a PIR sensor hooked up to the coprocessor, you could wake up the fin, do some like image processing. Maybe you want to do some machine learning to identify like what animal had walked past the camera. That's the kind of thing you could do, and then go back to sleep again. Yeah.
Hey, Mr. Allen.
Hello.
Thanks for joining, mate. Have you got projects on the go at the minute, Mr. Allen?
Many projects and some questions too. So
even better.
Yeah, I have a project that needs some clinic help. So so I actually showed part of this project, I think, on the last episode, or maybe earlier. It was the IAQ project, which is a device that shows an indoor air quality index on the display. And I included Wi-Fi Connect on that device so that when it's moved to a new location, you can establish internet access in that new location by, for those not familiar, it creates a captive portal, and then you can put in your new Wi-Fi credentials, and then it connects to the internet. But I guess what I missed somewhere is that I'm already using port 80 for my my device is using port 80 for the dashboard block for Grafana to show graphs of the various parameters. So now when you bring the device to a new location and you connect to the Wi-Fi hotspot, the captive portal, you get a Grafana 404 screen. So we're looking for a way around that live, in the field, and B, what's the proper way to prevent that in the future? How do you share port 80 if you want to have material on that port but still want to use Wi-Fi Connect? So
I think I can give you a hand here, Alan. Nobody else
awesome.
wants to jump in. I was talking about this with some people on the forum recently, and there's a few ways to solve this, but I see it in the forums all the time. That Wi-Fi Connect does need to be run in host networking mode in order for it to do its thing. But it does have an environment variable that I found recently to choose the captive portal port. I don't know if it's on.
Did you find it on the official documentation? If you'd followed the link, there. Alan.
Portal listening port can be changed to a non-standard port, so you can change the portal of port 8080, or you can change Grafana to a different port, but that's a bit more clunky because I would expect you go to Grafana more often than Wi-Fi Connect. So it's probably better that Wi-Fi Connect is on the odd port out. I think that's the cleanest solution without involving your own proxies.
Yeah, I mean, the thing is that phones, mobile devices, when they go to a captive portal, they assume that they're going to port 80 to try and find the captive portal. So if you change the captive portal or the port that the Wi-Fi Connect's running its captive portal on, you might find that some mobile devices just won't let you access that portal because you can't tell it what port to go to. And if you knew the IP address that the portal was being run over, then you can just go to IP, port, and it will come up. But it's not quite as seamless as it can be. So you may want to run Grafana on 8080 and have the captive portal on 80 to sort of cover that. It depends on whether you think, like, the majority, like for your IAQ thing, you've built a device, you're going to take it to an office, you're going to set up the Wi-Fi, and then you're not going to touch that again. So maybe it's worth going through finding the captive portal on 8080 or whatever port you put it on.
Okay, so if I were to change that variable, as Kyle showed, when you try to connect to the captive portal, are you saying that you have to know that port also at that point, or will the Wi-Fi Connect automatically do everything it needs to do?
I'm pretty sure you need to know that port. Because your browser, especially on mobile devices, but probably in most browsers, will take you to port 80, and you won't get what you expect. I'm pretty sure you need to put the port in manually. So depends whether you think you're going to be switching Wi-Fis more often or viewing your graphs more often. How clunky do you want to make this? If you just went that route, you could look at more complex solutions like a proxy on the device, or something that would restart your Grafana server, and if port 80 is already in use by Wi-Fi Connect, it would just kind of sleep until port 80 is available, and then it would start. So maybe you have both services running in host network mode, but they kind of like figure out whether the port's available for them to use or not.
Is your Grafana, is it actually the dashboard block, Mr. Allen?
Yes, it is.
Then maybe you should put an issue on that repo and get Mr. Chris to add that. That would be so cool, that if it put it over 80, unless something's already running in it, and then it uses a different one and lets you know which one it's running on. That would be a cool thing to add.
Yeah, like if we, because Wi-Fi Connect is pinging the internet to see whether it has connectivity, and then if it doesn't, it'll switch the access point, or switch the Wi-Fi into access point mode and create a captive portal and bind to 80. But I don't think it's binding to 80 all the time. So if you had the dashboard doing the opposite, pinging the internet, and as long as the internet's available, we are binding to 80 and sharing Grafana. But then once the internet goes down, stop everything, release the port, and let Wi-Fi Connect do its thing. It might be a way to solve that problem.
Right, we've got our first question from the actual public, and it's also about the Wi-Fi Connect block. How do we inform the other blocks of the name of the actual used SSID? So, I mean, the initial thing is, if I just go back to the same page I was just on there, you can, so by default, the portal SSID is going to be Wi-Fi Connect, but you can change that to whatever you want. So if you need, for some reason, other services or blocks on the device to know what the SSID is, then set it yourself, and then the others will, you can tell the others at the same time. Otherwise, it's Wi-Fi Connect, and you can put that in as the default.
So how about a hack, though, now that the device is in a new location and we can't actually kind of connect to it because all you get is that Grafana page? Like, is there a way to work around this without opening the device up and reflashing the the SD card, because we specifically didn't think we would need to do that? So there's no little slot in there to just pull the SD card out.
We tried restarting it and see which one starts faster, Wi-Fi Connect or Grafana.
Well, here's what we tried. Since it was last on my network, I gave my SSID and password to the office there and had tried to have them recreate my...
This has just been a long con all this time, and you fell for it now.
Is that even worth trying? We couldn't quite get it to work, but I think that was more the Windows 10 internet hotspot sharing than any other issue. But is that something, if it's possible, is that a workaround that would even work?
Yeah, you're in a tricky situation there. You can add networks to Wi-Fi networks, can't you? But you've got to have physical access to the device. You can take the SD card out, and I can't remember that Kyle will know the name of the file that you have to then add your Wi-Fi.
Yeah, it's in system connections. It's in
system connections.
System connections. You need to make a new Wi-Fi profile following the network manager.
So you can get somebody to do it manually. Like they'd have to get the SD card out of the device and load it.
Right, but what I'm talking about is since that device last connected to my Wi-Fi network,
it should work.
Can I recreate the Wi-Fi network in another location?
In theory, as long as it has the same SSID and credentials, when you power it on, it should try to connect to an SSID by the same name, and it shouldn't throw up too much of it. It shouldn't really care, because it does remember that the last one it connected to, and it will try on a power cycle.
But that also needs to have internet access, that recreated network, right? That seemed to be our problem, is that when you look at that hotspot that we made with the same SSID and credentials, it was saying no internet access when you look at it on a phone.
Right.
It depends whether something else is on the same hotspot that might, I don't know what kind of network connectivity is available, but if the hotspot, or if it connects to the hotspot automatically, and you also have, say, a terminal on the same hotspot, you might be able to, I don't know, ping it by host name or SSH into it. I don't think the captive portal blocks all internet traffic, although it might. I would hope it doesn't, but it could.
Okay.
Something worth a try, maybe.
Yeah. Well, we'll report back on how we solve this particular
issue. If you've not configured it to run on a different IP, then by default it will be 192.168.42.1. So if somebody's there on site, they can go to that and see whether it resolves to 80, or whether you still get Grafana if you go direct to the IP.
That was 192.168. I'm sorry,
142.1.
Okay.
I think part of the problem is, if we're looking at the startup order here, you powered this on, and the Balena engine immediately creates both containers, one for Wi-Fi Connect and one for Grafana. And the Wi-Fi Connect one's a network mode host, and it's starting while Grafana is created, and it immediately binds to port 80. So I think Grafana would probably always grab that port first, because it's the engine reserving the port, not a service running inside. So, and even if Wi-Fi Connect was faster, it would take a while for it to ping the internet and realize that it has to run in access point mode. So you're kind of stuck. Like, I don't think you can race it. I was joking about that earlier, but it would have been cool to just keep power cycling it, see if you eventually get Wi-Fi Connect, but I don't think you ever would.
Yeah. Well, I appreciate the info. Thank you. That was very helpful, clinic-wise. So,
Phil, can you open up the documentation page again? I don't know if we have the answers to this here, but there's a couple environment variables I noticed in the README. I'm curious what they actually do. I might have to look at the code. So activity timeout. I don't know what that means. Exit if no activity for the specified timeout. What kind of activity?
I think portal activity. So if nobody goes to the captive portal for a while, you can tell it that you want it to shut down again, so it's not just running forever.
Do you think it switches back to trying Wi-Fi again, or it just closes the portal?
I don't know, actually. Yeah, I've never tried it. The other thing that I don't see it as an environment variable, and maybe this is something else that we need to expose as part of, because this is a block. Wi-Fi Connect is now a block, but you can change. I think there's 3 different ways that it decides whether it needs to spin up the portal or not. I think it like pings Google's DNS servers, but I think there's another 2 different ways, but I can't see it as an option here.
No wonder mine always switches to Wi-Fi Connect mode, because I've blocked all Google DNS servers. Is that why my device is always going offline and turning into a portal again?
Yeah, but there are different ways, and I'm loath to read the code. Oh, the code, the actual. Wi-Fi Connect started out as a separate binary, and you used to have to build it and put it on your device yourself, push it to the device, and then this block sort of takes that code and encapsulates it. So we're going to consolidate it all so that the source code is the block. At the moment, the block's like a wrapper around the actual code. I'd have to look in and see like where there was a different way of you being able to tell it how you want it to decide. I'm probably not going to be able to read Rust live.
We don't need to right now. We should make sure we actually answer the question out of the comments. Did we actually address the question?
Yeah.
Okay, cool.
Yeah. Anybody else? Any other questions? We're not beholden to trying to go for an hour. I feel like we've covered some bits. I was going to try and do a live demo of the fin block, but don't know. It depends on our appetite of risk. What do you reckon, Buckles?
Why not?
Look at that confidence.
You can do it next time when he's in the comments and he's just screaming at you in the comments, all caps. You're doing it wrong, Phil.
Let's see. So if I share my screen, let's see. If it goes wrong, then we'll abort quickly and see.
End the stream.
Yeah. Oh, that's not like the best view. We might have to do it the normal way.
We should record. Well, we are recording this, but we should snip this for the documentation. Phil shows you how to sleep a fin.
Maybe. So if you look at my fin now, this is running the fin blocks. It's in this fleet, the fin block. It's not got anything else running with it. Normally you would run this alongside some other services, and the services would use the REST API of the fin block to do things like sleep it. But just for a demonstration, I added it to the fleet that backs balenaHub. So balenaHub is built out of everything that is running in Balena Cloud. Like we use that as a metadata store to show all those cards. So this is the actual block that makes the card appear on Hub, but I just added my device to it because it was the simplest way. So you can see that what it's done is it's loaded up and it's checked what firmware the device is running, and then it's decided whether it needs to download a new firmware and flash it for me. That used to be really painful, and now the block just takes care of it. And then it adds these tags. So if I zoom in a bit, you can see it's telling me that my device is awake. That's useful to know if you're not actually with the device and it's out in the field under a bridge or in a geocache box. What Firmata version it's running, what firmware it's running, what version of the hardware I've got. And if it was sleeping, it would try to give me an estimate of when it might next wake up. Because if you've slept it previously before this block, you've slept it with a command, you might go off for several months and then forget, when was that supposed to wake up again? This adds a tag.
Bearing in mind as well, if you sleep it, because you brought the Raspberry Pi aspect of the fin down, there's no way for you to communicate with it. So if you send a command to say sleep for a year, you've got to be ready that it's going to be asleep for a year unless you can go and stop it, because there's no way of communicating with it after that. It's asleep.
Do it, Phil.
Yeah. I think my mouse has just died, so I'll have to do it with the old trackpad, which might make life a bit more hard. So I was going to try and move to this type of view so that you can see me hold up my fin and you can see roughly the lights are flashing. Oh, those at the top, you see the red and green lights?
Yep.
And then I can put, so what I'm doing is in the host OS on Balena Cloud, but you would do this from another service. I'm just showing you an example. I can paste in a curl command that hits that REST API, and it will say that I want to sleep the device, how long I want to sleep it for, and then also I'm trying to do two things at once. How long to wait, so like a delay before it sleeps, because you may want it to do something and then go to sleep. You might want to send a GPIO pin or set a CPIO pin or something and then sleep the device. So I've said I'm going to sleep it for 20 seconds and then it's going to have 3-second delay. So if I send that command, hopefully you'll see my device, you see the flashy lights go off. So that's slept.
The tag's updated too.
And then, yeah, if I come back to the other view, oh God, why did my mouse have to die live on the internet?
And Andrew's gone.
So if I add that back to the stream, you can see it's sleeping. You can see there's an ETA wait time. I'll try and zoom in again.
You only got 20 seconds, Phil. Quick.
I know, why have I got... She's with my hardware. There we are. See, you can see it's got an ETA that when it's going to wake back up and that it's sleeping. And then the device, you can just about see in my camera, has got flashy lights again. So eventually that will come back online onto Balena Cloud and do its job. So what it would really do in the real world sort of scenario is you'd do something like Alex was saying earlier, it'd be sat sensing something and it would go to sleep for however long, an hour, let's say, and then it would turn back on, take a measurement, and then your code, whatever you're doing, a Python script or whatever, you would take the measurement and then ask the fin block to sleep it again. And then when it next wakes up, it takes a measurement, it tells it to sleep it again. So it's a very simple way of kind of cycling the power of the device to do its job and sip at the battery or the solar or whatever you're running it off. So there we are. Random live demonstration of the fin block.
Now, did it wake up?
With no mouse. Good question. Yes, it did. How do people survive without a mouse in real life?
I just wanted to see the LEDs, but you can share your screen again if you want.
Yeah, so it's awake. And you can see the LEDs. I zoom in. It woke back up. Yeah.
Nice.
Well, I'm glad that worked.
That's your backup fin that you just showed us. That's the second one you kept plugged in and away.
Yeah.
I'm not quite.
One I prepared earlier.
It's just the one I have on my notepad next to me at all times. Yeah. Did you see it's in a nice case as well? Like Alex is one of the. You can tell Alex works with hardware because his never has cases. It's like never touching a rubber mat or just whatever.
No fear of that, man. Whatever goes wrong, he can fix it.
Mine's in a proper case with DIN rail and.
I've got the same case on mine, and like me, you're only using the bottom half of the case because you still need to be able to poke it with things.
Of course, yeah. Cool. No last minute questions. So I think we'll wrap up there. Unless anybody's got something they desperately want to talk about. Speak now. Hold, please.
Did Andrew have something to cue for him? I mean, he's gone, but I thought he had something to share.
He ran out. Cool. Thanks, everybody. Well, we're going to have 2 weeks break now because we've got Balena Summit, which is our yearly get-together. That's next week. Following that, we always have a week where we do some hack projects and try and, generally what happens is we work 20 hours a day trying to get a project out by Friday. So we'll do that for a week. And then the week after that, we'll be back at the same slot as this, the Friday slot. So catch you all later. Adios.
Bye.
Bye.
Bye.